All right, hi, welcome. Thank you for being here. This is going to be very exciting because Spacebar doesn't advance my slides now. What do we got? There we go. This is what we're going to talk about for the next 2 hours and 11 minutes. Good deal. I don't want to waste time because there's a lot of stuff here, and I want to try to catch all of it and hopefully leave a little bit of time at the very end. I want to start by telling you the story of Betty. I like to tell stories at Oak Table World. This is a story that nobody's ever heard before. I promise. So meet Betty. I'll stand over here and read. Betty is a nurse shark. Her habitat ranges roughly from Nova Scotia to Buenos Aires, so the eastern coastline of North and South America. Betty has a rare genetic disorder that sometimes prevents her from migrating in the normal way with other sharks. Like thousands of other sharks today, Betty has a tracking chip implanted in her dorsal fin. This chip allows marine biologists to track Betty's movements through the seasons. Now imagine if Betty's chip contained insufficient identification to distinguish Betty from the other sharks. For example, if it had a ID that only went as deep as shark, comma, nurse, what she is, her type thing, then of course, that would be disastrous because then marine biologists would never be able to isolate Betty's distinct migrations. In spite of her remarkable instrumentation, they would never be able to locate Betty. So my goal here is to illustrate that AAS, average active sharks, is insufficient to solve the problem with Betty. So I would like you to remember that for the duration of the slide. Thus concludes my story about Betty. Are there any questions? Okay. So I'll begin by explaining something probably most of you know. So I'll go through this pretty quickly, but I want to talk briefly about extended SQL trace. What you get with extended SQL trace is basically a linear sequence of all the operating system calls and the database calls, the values that are bound to placeholders if you turn that aspect of the tracing on, and also query plan details. You get these lines that explain the execution plan or plans that was or were used with each of the SQL statements that executed while the tracing was turned on. So there's a lot of stuff in there. And what I want to do here, I'm gonna exit Keynote real quick. I'm gonna open Vim. I'm gonna drag it if I can remember which direction to drag. This is what a trace file looks like. Many of you have probably seen one. The top contains what we call preamble information, the name on the file system where the file originated, some information about what platform it's running on, what options are turned on, and things like that. Here you can see a parsing and cursor section, which begins, I believe the count of the equal signs there is 22. Somebody will probably run the number on that for me while I'm talking here. But you can see that cursor ID 139796211955624. That is how subsequent database calls that refer to that cursor, so this number here matches this number here. And the way that we know that this parse call was associated with that select default dollar from call dollar is because of the cursor ID match. So it's basically a key into basically a place in the shared pool where that SQL statement was parsed. But every line, like line 24, is a database call, and we can tell how long it took. It took 193 microseconds. The CPU tallied for the call was 1,000 microseconds, which you may think, how can something that only took 193 units of time have consumed 1,000 units of time? And it's how operating systems pull their R usage table for CPU statistics. So if you need to know more about that, I can tell you after the show. The binds thing here is basically saying that this value that goes all the way to the end of the line here, I didn't mean to just highlight that, this whole thing, that is the value that got bound in to this :1 here. And then there's an execute call, which took practically no CPU time, a fetch call that took practically no CPU time, and all this stuff in this file, and this just goes on for acres and acres and acres and acres and acres. The length of the file, let's see, I think I accidentally inserted something there. This particular file It's not one of our bigger ones. It's 67,000 lines long. It's not unusual for these things to be tens of millions of lines long. But that's what we're talking about. That's what an Oracle extended SQL trace file looks like. And that is the intent of this slide. Now, tools make it easier to read. And I'm putting up a tiny excerpt of the tool that paid my way to come to Oracle Open World this year. So there's lots of data that can be grouped lots of ways. And my team and I build tools that group this data lots of ways. And having many, many years, actually now I can say a few decades, I think 3 decades of experience with doing this, we have arrived at some, what I think you'll find to be innovative specifications for how to make your application easier to monitor and diagnose problems. So that's going to be the subject matter for the next 2 hours and 3 minutes. Okay, the joke only works once. All right, so the first one, you'll see I've made this little, I've mimicked the ticketing system that we use at Method Art Corporation called, it used to be called Fogbugs, and now it's called Manuscript, but I think I get the sense they're going to rename it Fogbugs again because it was acquired by somebody who seems to like that old name better. But here's a ticket that I wrote up for the slideshow here that says, what I would like is for a database operator, who's presumably a DBA, but not necessarily a DBA, must be able to control tracing of selected business tasks with this honestly almost magical PL/SQL procedure distributed by Oracle called DBMS Monitor. And I'll explain why it's magic in a couple of moments, but it's a standard PL/SQL pack that's distributed with every release of Oracle and every edition of Oracle. So it's an XE all the way up through Exadata, SE, EE, everything. So for example, what I would like to be able to do is say, I want to trace the next order entry job. Or I might want to say, I want to trace the next OE book execution. Or I might just want to say, I want to trace the next thing that Nancy does. Nancy Wells is having some performance problems on her system, and next time she runs something, I don't care what it is, I want to trace that. So that's what this ticket's really calling for. And Oracle's built to do that. Oracle, right out of the box, is built to enable you to do this. On the operator side, this is the procedure that the operator would call to actually invoke the trace of anything that labels itself as an order entry program, no matter, well, Oracle has this kind of a 2-tier approach to allowing programs to identify themselves. There's these things called session handle attributes, and I'll show you a picture of what those look like in a moment. But there are really 3 of interest to us. One is called module, one's called action, and the other is called client ID. So this DBMS monitor.serve modact trace enable gadget, which I don't know, maybe I can point this way. Yeah, I can do that. The serve modact trace enable, this stands for service module action trace enable. So what you do is you specify a service name, a module name, and an action name, or you can leave it null, or you can use this constant DBMS monitor.allActions, which essentially is null, which means anything that identifies itself with the module name of OE will automatically get traced after this thing is run. So to be clear, if there's something out there that's running that identifies itself as OE already, as soon as I hit that semicolon and enter in SQL+, that program is going to start being traced. And the magic part is that any program in the future, until I turn this off with a serve modact trace disable with the same service module and action names, until I do that, then everything that identifies itself as OE is going to get traced. So it creates a standing order for creating the trace data that I showed you in the VI session a moment ago. And there are 3 extra parameters that deal with how granular we want the data in the trace to be. And by default, these are the defaults, true, false, and first executions. They're well-chosen defaults. I like for people to use those values when they're tracing for the first time. So that really solves the first item of the first ticket, which was I want to be able to trace the next thing that identifies itself as OE. Now, it only works if your code sets its module name, and I'll show you how to do that shortly. But the second part of this ticket, if you remember, was I want to trace the next OE book. And it probably is within the realm of your imagination already to understand how that's done. It's simply a change of this line here from empty to the word book. So now only things, assuming we do this and not the prior thing, now only things that identify themselves as OE book will be traced. Things that identify themselves as OE book that are running now will get traced immediately when this gets turned on. And things in the future that identify themselves as OE book will get traced automatically. Really cool. There's another function or procedure inside of DBMS Monitor called client ID trace enable. And the client ID trace enable allows you to specify a client ID. So anybody whose client ID is set to NWells that's running now, when I execute this PL SQL procedure, it will immediately begin being traced, and anything in the future that sets its client ID to NWells will automatically be traced. So client ID trace enable sets up a standing order for tracing, just like serve-mod-act trace enable. It's fantastic. And this has been around since Oracle 10G. This is part of the end-to-end metrics mechanism that Oracle created back when the database was going to be utility that spread across who cares how many instances. This stuff can start tracing no matter which instance you're on. But it only works if your code sets its client ID, which I will now embark upon showing. So I mentioned this thing called a user session handle attribute. They're probably easiest to conceive of if you just think of the $session fixed view inside Oracle. You can query from $session and basically see one row for every session that's connected to your Oracle instance. And some columns in $session, service name, module, action, and client identifier store these values that a session can set for itself. So I'll show you in a moment what calls we use to do that, and I'm actually giving you a hint of it over here. Actually, I'll show you now. Let's say on this timeline where time's flowing downward, later is at the bottom of the timeline, earlier is at the top. When a session connects, it has no identification really whatsoever unless you connect using an application that sets it. So when you're in SQL Plus and you connect, you'll actually see, I believe, the module is set to the word SQL star PLUS. But if you call DBMS application info, this guy here, .set module, you can set both the module name and the action name for the session. So the session with that call is setting its own name. And the blue area over here will be known as OE book because its module and action names are OE and book. And when there's another set module call within the code path that nulls out the module and action names, then we go back to my little notation here of the gravel looking or concrete looking zone is the session then will be running without module and action identification for a little while. And here you can see that it sets its module and action to OE pick, and that lasts for a while before it says, okay, I'm no longer running OE pick. And then a few seconds later, it identifies itself as OE ship. So a session can actually do this. You can actually have code path that says, tell the world that I'm an OE book for the time being. Okay, now tell the world that I'm done being that and tell the world I'm something else. And if the session does that, this serve-mod-act trace enable thing picks up on that and will trace only the OE books in that sequence diagram that I'm showing you. So it's a really clean way to identify either whole sessions or parts of a session as the session identifies and re-identifies itself as what it is. So it's incumbent upon the developer to really start the ball rolling here, because without these calls here, the session has nothing but this gray concrete looking stuff. All right, I saw 2 or 3 people nod, so I'm gonna take that as a commit. And we're gonna move to the next page. So marking your code, how to do this is different depending upon which language you're writing your code in. If you're writing code in PL SQL, which I hope you are, Tone Kopelars and Bryn Llewellyn will convince you why you should be writing your Oracle applications in PL SQL, and I am fully 100% bought into their logic and their rationale, both from a security perspective, a maintainability perspective, and a performance perspective. Then you will set your module and action names and your client identifiers, something like this. So what we're doing in the first line is setting the identifier, and you don't have to set it to the session user. This is just an example of how you can use the syscontext function, which again is a standard part of every Oracle installation in the world, to grab a value and stick it into the client ID. So in our NWells case, then somebody who identifies herself or who has a session user of NWells will have NWells set as the client identifier as a result of this line. Next line is the DBMS application info.set module, which I talked about on the sequence diagram before. Your OE book code would go between this pair of lines which set your client ID and your module in action, and this pair of lines which basically unset them. And these are really important because Your session may stay connected for a long time after your OE book is finished. It may do something else. It may give the connection back to the pool, but there's still a connection. There's still a session there. So you want to make sure that you nullify these names when your code path is done running so that your monitoring tools don't continue to think the code path below this line here is still part of OE book. Does that make sense? Again, I see one face nodding. I take that as a commit. It's a big or. I don't know if you guys realize it. It's not an and at all. It's a big or. So if you're writing in Java using the JDBC that was kind of run out of business with some new 12c Oracle DMS stuff, which I'm still studying. But this is the way you do it. And again, it's pretty clean code in Java. It doesn't require that you do a lot of gymnastics. You basically take the connection, and there's a method called setClientInfo that you pass it an argument. It's basically a label saying which attribute do you want. And this OCSID.module is obviously your module name. So you can set the module to OE and the action to book and the client ID to some get username function result if you want. You run your OE book code, and at the bottom you nullify by passing empty strings, and there's a typographical error. If you didn't find it, I did. What page is that? Is it 20? 20, good. So 20, hopefully I only have to remember, 6 or 7 of those. 20. All right, Twisted and Pulled and Hurt My Neck in 1988. Rain Man reference, if you don't remember. Okay, 20. All right, so probably a better way to do it is instead of writing 3 lines of code ahead of every program that you write, you should probably factor that stuff into a begin task and an end task where you can just pass it a name. You don't have to pass it a name in the end task because the code already knows what the name is set to. And then put your OE book code in the middle. So of course that would be a nice thing to have. And of course, and I know this is small, but the reason it's small is because it's going to grow. There are going to be a lot more pixels added throughout the next hour and 47 minutes. The code could look at this is kind of just pseudocode. It looks a little bit like PHP. It looks a little bit like Java. I'm not sure what to tell you. A little bit like Perl now that I noticed the sub there. But all I'm saying is it takes a parameter, which is a task name. And in this particular code, what it's doing is it's splitting on a space. So it's taking the T guy and taking the first 2 things that are split by a space and assigning the first bit to module and the second bit to action. And then it's running setClientInfo, properties, module action, and then the value that needs to be pushed in for the client ID. And at the end, it's just setting all 3 of these things to empty. So again, pseudocode is pretty rough, but hopefully you can understand what's going on. Nobody's nodding, so I'll take null to mean true in that case. Okay, so now I want to move on to another ticket. And this one's a lot more complicated to explain, but fortunately I have slides that'll help me. Here's the thing. Our connection pooling application makes it difficult to isolate individual user experiences in the trace data. Does anybody relate to that? So you connection pooling, you're like, I don't know where the hell anything is. It's all just a big bubble gun. It's like if you go to an amusement park, not Disney, because they keep everything clean. For the record, I don't want the Disney snipers to come get me. That's why I didn't want to record, by the way, is because I'm going to say stuff like that. It's going to get me killed. But if you go to like Six Flags, Six Flags over Texas, where it like smells like a sewer all the time, and there's like you go up to the tree where you're waiting in line for the roller coaster, and there's the gum tree, where it's just a big old, you could hug it except it's covered in gum. It's like every teenage girl in the park has done this to the tree, and there's just like a massive gum tumor on this tree, and that to me is what connection pooling looks like in my mind. It's like just everybody's stuff. It's just like seething. It's like, I won't go into any more gross of a metaphor than that. I think you got my point. So it's hard. It's nasty. It's hard isolating stuff inside of connection pool. So I throw this Methodar workbench thing, and this is the software that produced the report that I showed you a while ago, and it produced some other stuff that I'll show you in a minute, but you'll be able to see how it like naturally comes from the trace data, what's in there. So if you want to duplicate the things that does for this purpose of this talk, you'll be able to see that. But the Methodar trick of identifying oceans, islands, and rivers, what the hell does that mean? Well, I'll explain it in a minute. I got pictures and everything. With this command, what the hell does a command mean? Well, I'll show you in a minute. It's a start. So we've got something that's a start, but we want to perfectly isolate experiences. So from your context clues, you can see we've got stuff, but it's imperfect. And what we want is for it to be perfect. So I'll explain all the imperfections, everything in this section following this. So it says we can do this by printing, it doesn't, this is me, I actually wrote this. We could do this by printing a unique experience ID, which could be like a universal unique ID or a GUID in SQL, to the trace file at the beginning of a task's execution, and then printing an empty experience ID at the end. This will give tools like these things that group data together a handle to group by. So I can say, I want to see all the instructions that have the same experience ID grouped in one little bundle. So it's basically me going to the tree and going, that little green piece of gum there is interesting. I think that was Susie, and I think Susie's cute. So I'm going to, I won't finish that one. But you know, an interesting experience you want to be able to pluck from the gum tree tumor thing. So really what I'm talking about is a report that might look like this, and in fact does in some universes look like this if you happen to know the tools that do it. But what I'm talking about is literally like this top line here. That blue thing is a UUID that says all the instructions that N Wells ran to execute some kind of task, and I didn't report on what the name of it was, but if I added module and action columns to this report, I could see what she did. I could see if it was an OE book or an OE pick or an OE ship or whatever. But this report's vital, and this is actually real data from a customer from the duration column over. This is stuff we can actually pull out of trace files. And what that 9.447 number, the red number, represents is how long it took Nancy to do something in the connection pool. Honest to God. Somebody felt 7.560 seconds when they did something, and somebody felt 7.525 seconds when they did something. And these numbers in that duration column, right here, these are honestly what people felt when they ran stuff that was recorded in the trace data for the connection pool. It's the most remarkable thing. I want to pause on this for just a moment because I want you to appreciate. This is looking at how long things took that people did. This is how long they felt things took when they did them. And we have detailed trace data behind every one. We know every system call, every database call that went into that 9.44 seconds. And there really aren't that many here. There are only 8. And for this one, there are only 9. For this one, there are only 15. But we know exactly what they are. We can go find them because we can drill in. The trace data allows us to say, okay, everything from when this experience began to when it ended, we know where that is. And I'll explain how we know in just a moment. So we can take that 9.44 seconds that was read on this page, and we can drill into it and see what the heck's going on. And we were shocked. We were absolutely shocked to find out that this was causing an application timeout that was causing like a baggage claim system to send somebody's stuff to the wrong city. And what we found out was that the 9.44 second long experience was caused by an NQ. We had no idea. If you look at system-wide monitoring things, NQ was like 0.0001% of total load on the system. So nobody saw this coming. And in fact, that NQ was caused by another session, which was doing a DB file. It was a single block read essentially, and it took like 8 seconds. So that NQ was held for 8 seconds because somebody else did a read between taking a lock and releasing the lock. And you can see all this in the trace. So I mentioned this thing, oceans, islands, and rivers, and you got a right to go, what in the world is he talking about there? Last, we're talking about sharks and a tree with a tumor on it, and now we're talking about oceans and rivers and islands. So I want to explain what I mean by at least some of this stuff. If you look at a connection pooling generated trace file, it looks like this. They invariably look like this. There'll be a SQLnet message from client that'll be kind of longish. When I say longish, I'm looking at the value of ELA here. This is in microseconds. So if you kind of imagine a comma between the 2 and the 6, and a period between the 1 and the 2, if you're from the US, that's 1.2 seconds. This is 4.2 seconds. This is 5.213 seconds. So longish SQLnet message from clients. Now, SQLnet message from client is what Oracle prints into the trace data whenever it blocks on a read call, R-E-A-D, syscall, that is on the connection that connects the client to the database kernel, to the server. So whenever the database kernel is finished with the most recently requested operation, it sends the answer back, and then it reads the socket, waiting for the client to send the next thing. So what's going on here is that these elapsed values, the ELA values that you see, are multi-second pauses between the application asking that connection in the pool to do something. So in between these long duration SQLite messages from clients, you'll see stuff for different experiences. And this stuff is what I was summarizing on that prior report, the 9.44 seconds to 7.50 seconds and so on. Is everybody okay? All right, so here's where the artwork starts to get really interesting. Such files have what I think of as islands of activity in an ocean of idleness. The default state of a connection is just kind of sit there until you open it, or until you grab a connection from the pool and then do something. So the do something is an island of activity. But it's very fancy, but you've got there. But an island can have rivers, and I don't want you to get too deep into the saltwater, freshwater analogy here, but water in the rivers kind of looks on a map a lot like the water in the ocean. So these islands of activity can actually have network round trips in them. So there's a trick here to using this oceans, islands, rivers metaphor, because you can't just say every time there's a SQLite message from client, it's a different island, because it's often not. It'll be kind of typically a bigger, you know, it may not be 2 seconds, it may be 500 microseconds, I don't know. But what we hope for is that the ocean lines in the trace file have longer durations than the rivers lines in the trace file, and they typically do. But what we end up having to do is, so trace files can have rivers too. What we end up having to do is kind of come up with a heuristic that says if a SQLite message from client duration is longer than some number, we have to figure out a number that works in this sentence, then we're going to call it an ocean. Otherwise, we're going to call it a river. Now, whenever you make an assumption or a guess, you really ought to ask yourself the question, what if I'm wrong? Like, how bad is it? You know, if I turn left here on a red light, we're going to die. So that's a whole different thing than if I turn left on a red light, we might just get a thing in the mail that says we owe the city $50. So you need to understand the risk of picking the number wrong if you're going to play this game of picking a number. So if you pick a number that's too big, then you're going to end up with the whole trace file with 1,000 experiences in it. It's going to look like the gum tree, and it's all going to look like one gigantic experience, all aggregated, literally concatenated together. So the smaller you go with your threshold between rivers and oceans, the more likely you're going to start breaking islands apart. Does that make sense? So what you want to find is like your happy little medium there. And if you've got a connection pool that's not too terribly busy, you'll find one. You'll find probably, you know, 10 milliseconds or something will be a nice happy number that if a SQLite message from client's longer than 10 milliseconds, it's almost always an indication that you're sort of shifting between one person's experience and another. So it's actually a pretty good heuristic. You'll notice here in the trace data, I've kind of filled in a little bit of the detail. You can see that there are these long SQLite message from clients that are oceans, as depicted by the ocean background on my Hawaii map there. And then you can also see rivers, which are denoted as, you know, watercolored things inside of an island. And you can see that their durations are smaller than the ocean durations. But you can also see that if we set the client ID the way that I prescribed a little bit earlier in the presentation, that we're going to have client IDs here that kind of give us a clue. It's like, hey, when the client ID shifts, that's like a different experience than that experience. So this is Nancy Wells's experience here. And then when the client ID shifts to Craig Shaftik, then that's a whole different experience. That's like a clue. So if we just set the client ID, we have additional information that informs us. We don't have to guess about the ocean size boundary anymore as much. But there's a problem, because if we just aggregate everything that belongs to N Wells, we're gonna combine that experience with experience C, and they're two separate experiences. Even though they're had by the same person, they're two separate blobs of gum on our gum tree tumor. I just said that for Kyle because he just walked in and he's like, gum tree tumor? What in the hell have you guys been doing? You can probably picture the whole thing though. So we need a little bit more information if we want to aggregate perfectly and not have to guess about, well, you know, different client ID shift. That's kind of a thing. That's kind of harder code to write a little bit, because if I would just want to aggregate by client ID, then I'm going to aggregate in a way that I really didn't need to here, because I'm going to stick A and C into the same blob. So what I really want is to fill in these blank lines that I've left. You probably all have some sort of an idea what's getting ready to happen here. When I do this, when I say, you know what, I'm just going to assign a distinct, guaranteed unique value to every experience when it starts, and I'm going to nullify it out when it ends. And I didn't show the nullification, but there would be a matching line down here that says star, 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 experience ID, colon, open, close, with nothing inside the parentheses. This gives us, as it turns out, everything that we need to group individual experiences, and we don't have to guess, and we don't have to wonder, did I pick the right number? Is 10 milliseconds right, or did it need to be 11? You don't have to do any of that if you do this experience ID thing. So how do you do it? Well, you can do it very easily using a function that's standard with every edition of Oracle. There's a package called DBMSLog, and it's been around since 11.204 at least, and maybe older than that. But inside of DBMSLog, there is a procedure called KSDWRT. And KSDWRT allows you to write to the trace file. So the argument to KSDWRT of 1 in the first argument slot means I want to print to the trace file. 2 would be print to the alert.log file. 3 would mean print to both. But we only want to print to the trace file. So we're literally going to stick the string, and I really have a typo here because on the prior page, I showed some star, star, star action before the experience ID, and then in the KSDWRT, I didn't put them there. So when I correct slide 35 after I correct slide 20, I will be putting the 3 asterisks and the space into these 2 KSDWRTs. So you can see in the begin task, we're setting a UUID, and if you want, you can push the thing on a stack so you can have nested experiences if you want. Like, for example, month-end close is itself an experience that may take a day and a half, but inside month-end close, there's journal import, mass allocations, post 7 sets of books. So if you want, conceivably, I'm just sort of mentioning here that you might want to nest these, you might not want to. But you can if you want. Everybody still okay? Got a couple more cases to go. We're going to finish like an hour early. This is awesome. Yes, sir. Yeah, and see, this could be a 15-minute conversation. I'm going to try to keep it tight. Yes, we want it to write only when tracing is enabled, but you'll notice there's not an if statement there in front of DBMSLog. So what we want is really for DBMSLog to say, if tracing is enabled, then write this thing. Otherwise, don't bother. Well, we should be able to look in $session at a column called SQL trace, SQL_trace, and it has 2 values, enabled, disabled. So when we query $session.SQLtrace, we should get the answer, am I tracing or not? Unfortunately, it lies. There's a bug. So I logged a service request, and it graduated from a service request to a bug really quickly. I logged this like 2 months ago. So we can't know. The problem is if you use DBMS monitor.servmod trace enable or client ID trace enable, it just doesn't get reflected in the value of that column. So the trigger that picks up the trace, it doesn't do everything that it should. So I'm sure it'll get fixed in 18.4, 19.1, somewhere in the future. It's a Sep 3. So don't hold your breath, but it's going to get fixed. Now, the other thing is that if I did a KSD DDT here, instead of a WRT, KSD DDT prints a timestamp into the trace file. And KSD DDT, if the trace file is not open, if you're not tracing, it doesn't do anything. It's a no-op. So it checks if tracing's turned on. If it's not, it doesn't do anything. That's exactly how I want WRT to act, because then I don't need an if statement. Well, that's a bug, because WRT does this and DDT does that. So that's another service request that turned into a bug about a week after I filed it. It's a couple months old. So if they fix them both, we're cool. If they fix only the WRT opens a trace file, whether you're tracing or not problem, then we don't need the other thing fixed. So brilliant question. That's the story. We good? All right, a couple more. Here's a ticket that says, well, I don't want to trace every OE book. I mean, how awful would the world be if every time I ran OE book, it like traced and it stuck stuff in my trace directory, and I got to constantly remember to go clean it out. And, I want to trace it every once in a while, but I don't want to trace it every single book order that we execute. So I'd really like to have some control over this. And that's what this ticket says. We don't want to trace OE book every time it runs, but it'd be nice if we could trace it for some percentage of executions. We want to control that percentage from a table that we can modify through a simple Apex application. I mean, how nice would that be? We're having a little trouble with OE book this week. Let's turn the knob up a little bit. Let's trace like 80% of them. So 4 out of 5 executions of OE book. I've got an intermittent problem, doesn't happen every time. Don't want to trace everyone. What the hell? Let's trace everyone for a half hour, see what happens, see if we can catch it. being intermittently naughty. So, and then when you catch it, okay, let's turn it back to where it only traces 1 out of 100. So that's what we'd like. Well, here is some code that will turn on trace for every execution. This is a procedure I haven't shown you yet. It's a really simple one. It's DBMSSession.SessionTrace enable. And basically the true, false, and first execution, this is the waits thing. This is the waits control. This is the binds control. And this is the plan stack control. So we're not specifying any information about the session because what we're doing is we're tracing my session. When this code runs, my session will be traced. And of course, your OE book code goes between these two things. Now, the reason it's indented funny is because I'd really like for that to be sort of hidden inside of a block that's conditional. I want an if statement that says, if I should be tracing OE book, then do this. And then at the end, you could put the same if statement around the if I'm tracing, then turn it off, but it's cheap enough to turn it off without even checking. So you can simplify your code that way a little bit. So what would the should trace thing look like? This ends up being kind of interesting. And again, you know, it's just software. You write code to do whatever you want it to do. You know, we're used to buying code that does what somebody else wants it to do, but when you write your own code, you can make it do anything you want to do. And I want code that's diagnosable. I want code that when I want to trace more executions of something, I can make that happen. So here's one way you can make it happen. We can write a should trace function that looks like this, where we've got a trace control table, like in the bottom right. It's a real simple 2-column table. It's got a task name and a proportion. So what I've specified here is that I want OE book to trace 5% of the time. 0.05 is 5%. And what the code for that can look like is I'm going to select the proportion from trace control where the task name matches the argument that came in. So if the argument came in as OE book, then I'm going to return 0.05 from the select proportion thing. And then what I'm going to do is I'm going to flip a random coin between 0 and 1. Right? The DBMS random dot value will do that. So I'm going to generate a random number between 0 and 1. And if that number happens to be less than the proportion that I selected from the table, I'll return true. Otherwise, I'll return false. That makes sense. Well, I like it when people take pictures of my slides. It means they want to look at them later. Or at least it means they want to pretend they're going to look at them later. That's just as good. That's just as good. So this is a picture of really what's happening on a number line. If we flip a coin that returns a random number between 0 and 1, 0 inclusive and 1 exclusive, then there's only a 5% chance that this number that we randomly generate is going to be less than 0.05. So it perfectly does what we want to do. And basically what we're doing, whereas ASH samples over a time dimension, right? Every session gets ASH data collected for it, but only once a second. So it's sampling. It's not random because it's 1 second intervals, but it's sampling. Well, this is a way you can sample with trace data. You're getting a full story for some things, but you're not getting any story for a lot of other things. And to be able to control how many things just by simply writing an Apex application that will allow you to change that value with the slider, that's pretty cool. So it gives me the control I want. If I don't want to trace any OE books, I turn this to 0 because there's no way that the random number that I generate can be less than 0. You know? So this thing will always return false if proportion is 0. It'll always return true if proportion is 1, and it'll return true half the time if proportion is 0.5, for example. So yeah, you know, you write other, like, I didn't put all my try catches in my pseudocode. Yeah, but I hope you get the point. It's something that you can do if you want to, and then the new code, the begin task code would look like this. It would have the, if I should be tracing, then do this stuff. And I could actually pull the DBMSLog.ksdwrt inside of that if statement. Yeah, I mean, that would solve the problem for some calls of ksdwrt. And of course, at the end of end task, you would do a session trace at disable, which you could look up whether I'm tracing, but it's just as cheap to turn it off without looking it up as it is to see if I should turn it off and have it not be necessary to.
Is it because
sorry.
Is it because that it piggybacks the set time input that you don't set the time after you tracing?
Yeah, so Peter's question is it because of the piggybacking? I haven't mentioned the piggybacking thing yet, so I know you know what it is. but I haven't told everybody else what it is. Essentially, when I did the JDBC thing earlier of the set client info, and then I said set the module to this, the action to that, and the client info to this other thing, I didn't mention when I showed that slide that those don't induce a round trip to the database. It looks like 3 database calls, but they're not. There are 3 calls that execute in the client that just set attributes of the connection. And then the next database call, those attributes are pulled through with the database call itself. So there are no extra round trips incurred by setting the module and the action and the client ID the way that I showed you before in the JDBC code. In the PL SQL code, you go, well, it's round trips when you call DBMS application info. Well, no, it's not round trips if that's inside of a PL SQL block that's executing on the server. It never leaves the server, it's already on the server. So there's no round trip required there at all. So Peter's question is, and I may have lost the essence of your question during the explanation, but I think I can retrieve it. So what we're doing here is I'm saying that we're writing a set client info function that does all that stuff that I showed on the JDBC page. And the module action and client name gets set in this line of pseudocode, but there's no database calls that actually happen until later. And this session trace enable would be the first database call that takes place in this code path. And so therefore, those values would get piggybacked onto this call into the database when that session trace enable is executed. So I think, Peter, the short answer to your question is yes. You're welcome. I'm a master of short answers. Yes, Peter. Yes. All right, next case, we good? Am I out of time yet? We're still good? All right, I'll use it all. So I'd like to be able to manage the tracing levels too. I don't necessarily want true, false, first executions every time. I might want something different. Well, okay, this is some information about how we don't want to always do true, true, all executions. For you later. What I really wanted to get to by showing that slide is how to avoid measurement intrusion effect with using extended SQL trace is basically 3 steps. Number 1, always when you go in blind to a place you've never seen the app before, use waits equal true, binds equal false, and plan set equal first execution. I used to say binds equal true, but I've gotten burned 2 out of probably 500 times by applications having really poorly designed code that has really lightweight executions. So you might process 1 million rows with 1 million different exec calls, processing 1 row at a time. And when you have SQL with lots of bind variables, and that SQL doesn't take very long to execute, say we've got 200 bind variables that need to be listed in the trace file. Well, there are 5 lines of trace data for every bound value. So 200 bind variables would mean 1,000 lines of trace data. Unfortunately, when Oracle writes trace data to the trace file, it does it with 2 write calls per line, 1 for the content, 1 for the new line. So it'll be 2,000 extra write calls per 200 microsecond execution. So exactly. So I've gotten burned like, why is this taking 84 times longer than it should? And then the sad part is, well, it's because the application needs fixing, which is fire tracing to begin with. So forgive me. But the sad part is it tends to stimulate clients' immune system towards tracing. I'm like, well, by God, I'm never going to trace again because the son of a bitch takes 82 times long. No, it doesn't, but it did because we made a mistake by setting binds to true. So if you don't know the app, it's like a strange dog. Does your dog bite? All this protocol you need to go through. Well, set binds to false. And then if you find out you got lightweight executions, go, whew, it's a good thing I didn't set binds to true on that first deal. Same argument applies for first execution versus all executions, because what all executions does is essentially says every time there's an execute, I want to print the whole execution plan to the trace file. Well, if the execution plan is 732 lines long and my executes are only 200 microseconds long, again, same problem. So do that, and then fix the lightweight row by row processing problem, which is why you're tracing it to begin with. That can't be fast ever. And then you can use true, and even all executions if you'd like to. So the new code is basically widen the table and then select more stuff from it. So we can see what did you want bind to be? Instead of having to bind hard-coded up in here somewhere, it's now pulled from the table. This is important. I'm not going to be able to spend a lot of time on it, but Oracle e-business, way back before it was even called Oracle e-business, back in the day, right? It's always had this feature where you could go like help debug trace, which sounds really helpful. You know, Nancy's off stranded in Golden, Colorado somewhere, and her thing's slow, and she's like, I'm going to help debug trace. Well, when she clicks help debug trace in the app, what typically happens is the tracing is immediately enabled for her session. It's like, okay, I got tracing turned on. Now, what was it I was going to do? And the phone rings. Oh, yeah, this is Nancy. Oh, shoot, yeah, I'll be right there. She goes and does her thing, helping a colleague, and she comes back. Now, what was I doing? Yes, I was going to book an order. So she books an order, and then a DBA calls like 45 minutes later and is like, hey, did you mean to turn on tracing? Oh, yeah, let me turn it off. Help debug, stop tracing. And so what she ends up with is a trace file that, yeah, that's the story I just told. What you end up with is a trace file that trace is enabled in the distant past, and then her thing, the red thing there in the middle, is the trace file you want, but the trace file you get is a lot longer at the top and it's a lot longer at the bottom. And sometimes it's not a big deal. You know, you can go and do surgery with the right tools, but it's just more steps. And you shouldn't have to do these extra steps because it's software. You know, it should do what I want it to do, not what just, you know, it wants to do in some mistaken way. So a bad thing to do is allow a user to turn on tracing. A good thing to do is allow a user to express the intention to trace the next thing she does. And those are two different things. So help debug trace should set a Boolean, and then begin task should inquire about the value of that Boolean. And then your code would end up looking kind of like this. If tracing is intended, and you can imagine what that function would look like. Or if I get some stuff back from the should trace thing, then I'm going to go ahead and turn tracing on. So it all kind of like folds into this one little begin end task pair. Now, I think I'm about out of time. I think I'm actually 57 seconds past out of time, but I'm going to wrap up anyway. So the wrap up is, there's lots of stuff you can do, and I've got just a list. You can trace just the first OE book execution every hour. You know, you can get fancy with, I want to trace this percent of Larry stuff with that percent of Nancy stuff. I want to trace, this is a good one. I want to trace some percentage of executions, but only ones that have durations that are one of the top 10 variance to mean ratios in my application. I can actually do all that stuff. It's just, you know, it's just like me thinking of something I want and then figuring out, okay, how do I write this? It can be done, and it can be done efficiently. Trace only if the job is less than P% complete after running for so many minutes. You know, if it does like the $session.longop stuff, you can actually get this feature implemented. And could you do these even if you don't have source code access? And the answer is, you know, for some of them you can actually, because you can do function interposing, you can use triggers. There's all sorts of crazy stuff you can do, but it's way better to be able to write the code right to begin with than start to try to put your fancy stuff in there. So there are hundreds of specs you can meet, literally. Trace when you need, persist every response time to a table or a file, predict response time problems, track pathways through the app, you know, write harvesters, uploaders, profilers for the data. There's this whole, it's just a, performance is a feature, and that's what I mean by it. There's all sorts of things you can do when you have a performance mindset. Anyway, if you're writing your own code, it's no big deal, right? Write whatever you want. For more information, these two books, the book on the right is actually gonna have a third edition out sometime, hopefully around the end of the year. It's gonna look totally different. It's gonna have a bright blue top third, so you'll know. It's not gonna be like, oh, do I have the new one or the old one? You'll know. But it's going to have a lot of stuff like what I'm talking about here in it. I've got two more slides. They're both pretty important. This one is me thanking the good folks at Sintra, my employer, for paying my way out here. Visit them at Sintra.com. Any of this stuff that you want to do, Sintra can help you do. So if you want like a consultant to sit there with your developers for a couple days and like teach them how to put this stuff in their code, we got people that do that. And that's pretty much it. Thank you very much. I'll leave this disclaimer up just in case anybody's interested. But thank you very, very much. And I'll look forward to seeing you again next year.